Right, back again. Just I've done a little bit of stuff in the meantime. Um, so yesterday I did a stream and was just looking into materials for entity component system and how to handle materials in like a bindless rendering setup. Didn't get to um, complete that yet, and these were actually before they were textured normal maps. I just had a look in RenderDoc. Basically, I quickly got a DDS loader working, which is working, and it has mipmaps in. I'm also using a texture builder tool. It's called Texture C from BGFX. Actually, the repository is called B Image. You can find that on GitHub. Quite good. Can do mipmap generation, different image formats, cube maps, and actually added support so it can generate texture arrays in a fork we have. So basically what's happening here is I've got 2048 texture, but it's not selecting any of them, and it's just black without mipmaps. So basically I'm just gonna go into sorting this out basically. So what the problem is only copying the first level of mip level, and there are also some kind of weird assumptions here. Like it is assuming the image is RGBA, which isn't necessarily correct. So while I'm here, I can tidy that up. So this function's getting pretty big. Create texture can do quite a lot of stuff. Basically, it can take a texture info, it can create the texture itself, it can create a resolvable one if you create a multi-sample AA. It can copy data into it, and then it can also create shader resource view, one for the MSAA, render target view, depth stencil view, or unordered access view. This is to try and make it a bit simpler. So Direct3D and Vulkan, you have to create shader resource views. You have to create, everything for a texture resource is just the kind of the data, and you have to create everything else. Whereas in Metal, it does this for you, where you can set some flags and you get a default view for the texture based on some flags. And so my plan was to have a texture, and I already have this. A texture can be a render target, a shader resource view, unordered access, but you would be also create your own views to alias that data if you wanted to. So you still have the same level of flexibility, but then you just don't have the baggage of needing to create a texture, then to create the views for it, and then create heaps to upload to it, and all of that sort of stuff. So basically, this function is quite big. So my plan was to take out the upload data into its own function, just so that becomes a bit cleaner. So it's all of this chunk, and let's see where we are. This is now a little bit tricky. It's a big old file, and device. What are these? Okay, create element. So on a device, I can create this function. Upload texture data, and do you want a self? mut. So okay, so creating a internal function that we can call. Data is an option slice of t, I believe. So the internal function to upload the data it's going to take is part of the device. So it has a self. We need to pass the texture info. We're going to have data, which is an option of slice t, I think, and then we actually want texture info first. We could technically, I reckon it might say not an option, and then we don't have to call this function if we don't have it. Texture info, we can take a reference to that. Okay. Lots of issues so far. It's quite tricky coding at this size because I am used to the much smaller size text. I can see kind of scopes and a lot more in one screen, but it'd probably be a bit hard to read on a stream, so I'm kind of struggling around with that a little bit, not gonna lie. Right, create committed resource. What's this saying? This operation is unsafe. So basically this all needs to be unsafe, really. Initial kind of data. We have a row pitch, upload texture data. So first thing I'm going to do is just make sure the function still works. This is row pitch is, that should be row pitch, not info width. Times 4. That's all right. Still got some problems. The XGI format, a resource, an initial state, and this returns errors. So this can return a result. Super errors, and then we need resource, initial state, and DXGI format. Texture info, data, resource, which I believe is going to be in Direct3D12 resource. The initial state, transition barrier, ID3D12 resource, D3D12 resource states. It's got a bit big to read on the screen, so I'm just going to bring it all down. think this might be super result. Nope. These up. So I'm just looking for an example where I am returning a result. Oh, it's this. The problem with this is the ambiguity. I just want regular STD result, but Windows defines its own. Windows RS defines its own result, so that causes a bit of problems. Then this whole block needs to obviously return okay. That's this. Okay, that is okay. The XGI format. Pass that also in resource XGI format is the XGI format enum. Okay. So then we've got that function, it's unused. And we're going to use it and create texture. So we create a resource, create a resolvable texture, an SRV. It used to go there after creating the resources. Oops. Upload data. So this had before if we have some data, upload texture data itself. Upload texture data, texture info, which we already have. We have data. We have the XGI format. We have resource and initial state. And we can bubble that through. Resource spelled incorrectly. Pass a reference to the resource. Okay, cool. So this is in the core D3D12 backend. So I actually need to rebuild, and also to begin with, I'm going to run this basic example and just make sure that everything's working all right. Oh, crashing. Copy texture region. Damn. Okay. Crashing in there. Should have really pushed before I did that. I hadn't run this. Copy. I changed that with this was called info.width times 4, and so was that. I don't know if it's to do with that, but copy texture region, source and dest. Right, crashing, same place, I assume. Copy texture region, P resource. Okay, so it's to do with the resource, passing the resource as a reference. It must be. So let's see where we use resource. So that was actually possibly all right. Okay, so it's taking a pointer to a pointer essentially, which I don't need to do, which is, you know, you can kind of run into trouble quite easily there. Running examples. Okay, there we go. Cool. So it's working again now. And also I can probably go back to I'm getting so lost in the code because it's massive text. This can be row pitch. And so this, God, row pitch. Row pitch. Which should also work. Right, cool. So this one's assuming RGBA formats. You might not have an RGBA format, so that at least fixes one thing. Now, there's a few things in here. When we upload, we have to align the pitch of the image to a power of 2, which in the case that if we have a power of 2 image, we actually don't need to do that. And so doing this line by line is actually padding out the pitch. So what I think I might do first is make it so if we have a power of 2 pitch and upload pitch, we can just do one big copy, which I think is going to, you know, in general, it would be good practice to use 2 textures, and then you're maximizing your memory usage and also optimizing little details like this. So if row pitch is equal to upload pitch, that's going to do it like that. Copy over the and then this one can go essentially just one single copy map data. So what we're doing is in this one, it goes through line by line and then doesn't copy the whole upload pitch, it copies a smaller amount and leaves a bit of padding at the end. This one will copy in one go. Ooh. So that's the wrong. Hold on. So these ones aren't powers of 2, and these ones are, because these ones that are broken, they're only copying the row pitch, not the entire row pitch. Slice pitch can be called, I think it's called slice pitch for format. So that takes into account the width and the height. Row pitch and slice pitch. D3D12 calls them row pitch and slice pitch. So we want to copy an entire slice in one go. And that's actually a test that I know that was working correctly. Cool, that's working. Shader actually, the texture. Hotline data, source shaders. The bottom right square with the bindless kind of texture sampling is just being stomped to green. So what I'm going to do is just sort of modify that so it's still a texture, and it just to make it a bit more demonstratable. Sample org adds something. I wonder what it would look like if I multiply it. I didn't actually think it was a texture, you see. I think it might not be building the shaders. And compiling shaders isn't happening for examples automatically. Now it's crashing because I'm not actually using these guys. Okay, you can kind of see. What's it do? It multiplies it by RGBA, which is passed in from as a push constant. Okay, that makes it green. And then we sample this other, texture sample, texture 3 sample with an offset. I don't think that's really doing anything. So the texture is originally blue, and then the push constant turns it green, which is weird. Well, it's obviously not pure blue. Okay. So now I know my basic textures are working with pitch and slice and handling that nicely. You can go back to Direct3D12 implementation, and then we can go to upload texture data. So the reason we need a resource dimension buffer which we copy into, and then we upload data into it, and then we copy that into the sub-resource. So in the case of mipmaps, the sub-resource index is going to go 0, 1, I think. Maybe I'm wrong. Row pitch, depth is 1. So in terms of a sub-resource, I think the sub-resource is usually a mipmap. Let's see. Gonna have to just use this for research. an arrayed, mipmapped, or planar texture. So the sub-resource on a mipmapped image is the mipmap level. But then, what is a sub-resource of and then if the sub-resource of an array texture is the array level, or arrayed or mipmapped, maybe we use depth as the copy. I'll get that. I'll deal with that when I get to it. So what this essentially means if I make a new function, I can call it in a loop. Let's see what we have to do. Info, format, width, height, info, info. Right. I'm going to make a function called upload texture data, which takes all of these parameters the same as this one, and then this one's going to become update sub resource. And what it means is I can remove the texture info, texture info. The info is going to be removed, and I'm going to go just straight with I'm using U64s for these, width, height, and depth. And then sub-resource. What was it? Sub-resource is a uint, so we'll call that S32. Oh, it's I32. And then my data slice can be offset, and then I'm going to work all of that out in the inner function. Oops. So now this is kind of becomes a wrapper function. Upload data sub-resource. Few parameters. What are they? We need format as well, and that is super format. Okay, so then we can just strip off the info. Info height. And this will need some extensions and modifications to support mipmapped 3D textures and mipmapped texture arrays and cube maps as well. And I have some cube maps and I have some texture arrays that I've generated. I do have quite a bit of all the code from different projects, not in Rust but in C++, so it is making it quite easy to catch up. Not surprisingly, but it kind of is in a way. And this can just bubble that or return that. this is upload texture data sub resource, and then we just need to pass the correct arguments. So we want, I'll go slowly a bit at a time. I'm just gonna do pass these through, make sure everything works. Oh, catch stupid things like that, of course. Yeah, pass the depth, sub resource, which is in this case 0 hard coded. Data pass straight through. Format. Resource and initial state. Okay. Depth is U32. Okay. It's just a wrapper function, which will become a bit more complicated when I get time to add the mipmaps. Let's see. The samples are annoyingly not building, and they should be building. Shaders. Okay, that's still working. That's good. Right. Let's get that. Get rid of that. Just double check that this still runs. The main client. Sub-resource and depth aren't used at the moment, but that's fine. There are two things that I want to fix. Right, okay, so can't see anything at the moment. Actually, I'm going to quickly go through these samples. I did change some data paths earlier. Just tidying API up for file loading since I added the DDS textures. And they're still all working, so that's cool. Right. Draw C buffer material. Right, we're back. Okay, I assume the texture's loaded. Even if you go 1:1, the 2K is still too high res. It's not selecting it, so it's wasted memory in terms of my screen resolution. But doesn't matter. Depth sub resource. So now depth is used. It should be 1, so it shouldn't have any effect. Sub resource is still unused, and that's what's going to be start to get hooked in. I'm going to call this in a loop. Okay, sub resource index, and this will allow us to also support non-power of 2 MIP levels. I expected a U32. Was it U32? I thought it was int on the docs. Oh no, uint. Oh, I did it wrong. My bad. Upload texture data. Right, so now, what's that 0? Sub-resource hard-coded to 0. Right. So for this, now, I'm going to go for mip in 0 to info mip levels. Now, data also needs to have an offset. Here we go. So this is a bunch of stuff. Mip width, these are going to go decreasing in size. We've got one for height, and one for depth. Height. Oh. And I'm going to just pass those in mid width, mid height, mid depth, data. Can we do that? This becomes okay. Right. Data offset. Data is a slice of T. I really want it as a U8 and to offset it in bytes. So maybe upload texture data sub-resource can take a U8 slice. Let's see where we use data. Data as a pointer, offset data as a pointer. Right, I'm gonna, data is a pointer of type const U8, so it's gonna change. And that means then data we can just do source, let's just say source equals data, and then you can just say data dot offset, can we, as pointer. Which that means this is wrong. Like data iter, and that's going to be data as pointer. As const U8, like that. Const U8 data iter. Okay. We can pass data iter straight in. Mut data iter. then we can say data iter equals safe. Data iter dot offset and then so we need to work out the slice or the size slice pitch. Slice pitch format info.format mip width mip height. So we offset the data by the size of the current mip, then we downsample. It's coming up a U64. High size. Offset does that. There's another one which God, I always forget what it's called. It's a U size because offset can obviously go bidirectionally. Pointer. Oh, it's add. Is it add? Add takes. Oh, the U size. We're always going upwards, so I don't want to feel like that's the correct one to use, although it doesn't really matter. Okay, so now the MIP, we calculate the next MIP level always by dividing by 2, but we need to clamp it to 1. And always perform the divide. If it's power of 2, you can do a shift instead, which will probably be a more, God, spelling errors. MIP height and then MIP depth. The shift will probably be more like less cycles, but dividing is easier because then it can handle non-power of 2 textures. Okay, we don't need a generic argument on here anymore. Right, that's working. So first things first, let's just check the old bindless texture sample to make sure the basic non-mipped textures are working. This shouldn't come out any differently. It's doing MIP level 1 correctly. Then now let's go into more exotic world. Let's double check before I go there. Transition barriers, command list close. Right, so what do we do? Self command list. We do one each time. So this command list, I propose we would just execute these, all of this doesn't need to be done in the inner loop. It can be done after we do all of the MIP levels. Yeah, we do have a self. Oh, it's unsafe. Unsafe. Okay. So we close that. We create a new command list. queue it. We create a command list from that slice of command lists. We signal 1, wait on the event, and then reset it. Like that one, this one to do, I'm going to put, we should be able to signal we can create a fence anyway and do that in here. So basically we're waiting for the command list to complete so it can be reset. That could probably be optimized. So if you're doing lots of texture loads, you don't wait for each one, you just reset and flush afterwards. So sometimes it starts to leak into, I'm trying to add all of this stuff in here so you can create a texture from the high level, say like in the draw API. Where is it? Oh, draw. Right, load texture from file. Here's the function. We call image load file. This loads it from disk, gets the data. Then we just call device create texture. Pass it the data and the image. Quite simple, but underneath it's creating, it's using the upload heap, it's creating command list and synchronizing. If you expose that to the higher level, then every kind of thing that's doing texture loading becomes a bit more complicated, which might be desirable in some places, but for the case of the samples and the things that I've already worked on, the convenience is, it's nice to have. So part of what I'm doing now is trying to thrash these things out and figure out what's going to be the nicest way, the balance between having a low-level API, which you can make more ergonomic by wrapping these things up, versus exposing things and making it manual. And one place that's already happened and it's turned out quite well, I think, was, oh, right, device removed. Creating separate heaps. So the device has heaps for render targets, for shader resource views. So you can create one and it'll automatically create those for you. But you can also create your own heap and then create a buffer at the moment with that heap, which made it possible to do a different kind of instancing method. And I'll probably do the same for textures. So then what happens is a higher level graphics API could create its own heaps and manage texture loading and kind of take that away from the device. And so I think that strategy has been quite good, that you have a basic one where you kind of, I don't know, a bit more like a Metal or Direct3D12 style API in some ways. And then you also still have the control to do things manually, and you can then just sort of get the best of what you want out of it. So that crashed. I think that going into oh no, so even the bindless sample was crashing with that, which means I'm just going to copy that and undo to the point where okay, that's it. So see if I run bindless again. Okay. That's working. Let's see if the samples are working. Materials working now. So problem with this is it's going to basically block and wait to upload and copy the data for each mipmap for each texture. Okay. It didn't crash, but the data's not there. I'm going to run renderdoc and see what renderdoc says. I assume my memory is going to be empty. Meshes, texture viewer. This one's bound. Oh, yeah, my MIPs are full. Come on. Right. My MIPs have worked, albeit with a slow command buffer, but they're there. So now it's the sampling of the mipmap, and it must be to do with the sampler. Right, okay, well, I mean, that's quite good. I mean, the fact that it doesn't crash. Close that. I'm just going to run this one in the debugger and just check there's no validation errors. Oh yeah, here we go. Bunch of stuff. So okay, so a bunch of validation errors from presumably, well, it's on copy desk, copy texture region. So transition states on the command buffer or on the resources aren't correct. And then I did have that open. Graphics root signature. Static samplers. Border color. Wrap. Min. Mag. Mip. Linear. Core texture. An input texture is black here, but oh, I know what. I'm multiplying by alpha in the shader. Because previously I was using the bare shader. So if this is not, I was expecting the alpha would be 1 in there, but maybe I'm wrong. So here we go. We sample the texture and we multiply its albedo by that. I wonder if this is it. No. That's weird. Let's see. Oh no, this is 3D texture. That's why. How is it a 3D texture? 3D texture 299. That's not a 3D texture, so that's my problem. I'm gonna have to change Direct3D. Keep that on screen. Okay, back to Direct3D12. And going to have to. I know what it's. Right, so the issue is going to be image data. The image API. DDS. So for the DDS file. STB image. So if they okay, this else is texture type 3D. So it must begin with complex because it's got mipmaps. So if it's not complex, so anything with, oh, you're there. Sorry, that's my cat. I'm just gonna have to go and feed him. I'll be back. Say hi. Yeah. Oh. Come on, let's go. Right, fed him. Okay, so this whole arm of this if else basically needs to come in here. One of the problems I find with these kind of statements in Rust which return, where you're following through the return type, you can get quite branchy in terms of trying to wrap it all into one statement. So in the case of if it's complex and else if DDS.depth is greater than 1, then it's a volume. Otherwise, well, it could be a texture 1D with MIPS. I don't know if can a texture 1D have mipmaps. Not sure. D3D12 and mipmaps. Maybe resource dimension. I'll have to have a think about that. So This is if it's complex and if it contains all faces. So now I've got this same branch basically for mipmaps. And then it's sort of duplicated for a non-mipmap ones comes down this path, and then a mipmapped one comes down this path. Would like to be able to minimize that and make it a bit nicer. I've got a few other places that same kind of thing happens. Come on. Right, there we go. Cool. But it looks to me like it's not selecting the mip levels because it's still noisy. Like at this point, they shouldn't be that shimmering and noisy. So back to render doc. Take a grab. Oops. Grab that. Got textures. These are the textures. It does have MIPS. You know, it does have MIPS. And my sampler, maybe it's it must be the sampler now. Set root signature, static samplers. Okay, so here's my minlog bias, minlog max log, both at -1. I'm going to change the minlog and max log on there to not be. I'm going to change it to 0 to if it's -1 it might be, it's selecting the top level MIP, I think, and I don't think they're useful defaults. I don't think they are the defaults, or they should be the defaults for it. So they should be configurable in real time. So it was the debug PMFX, wrap linear, that's in hotline PMFX, wrap linear. I think it's got minlog. Minlog can be 0. Max log. Well, in this case, I'm going to put it to 1,000 because I think they will get clamped. They don't need them, and they don't need them. You can use JSON, but you can use kind of syntactic sugar. So I'm going to say minlog maxlog defaults are going to change. That's in PMFX. This was the problem before where I'm going to run it when it's running through render doc. I wasn't really clear what was happening with my hot reloads or seeing any errors. Right, that's worked. It's worked. Look, beautiful. Aliasing gone. Mipmaps working. What is, we need FLT max. Minlog should be 0. Max should be FLT max for the time being. this isn't really a problem. I can initialize it to a large value. 1024 MIPS. Would it be 2 to the power 1024? Can't be bothered working it out. I was just trying to work out what would it be. If I just put a fixed in large number, it usually, I think in sort of C++, you could use FLT max as the default, and that would be always going to be huge. But I'm doing it in Python, and then you also have to specify it in the script. Or maybe not, actually. I think I could do max value of a float. That would be the best way to do it. Okay, cool. So actually I wanted to just double check this wrap linear. So I take these off. Okay, it's failing. Hot reload's failing. That was since I changed my data paths. My current directory. So I'll fix that while I'm here. Don't want any casualties. As I go along, I should have checked that a bit earlier. The reloader, when it's reloading, it issues, or is it plugin? PMFX has it and the plugin has it. I should try both. So hotline path, we get data path, it needs to go back twice. So what I did was change this data path function because some things were adding data and some things weren't, and it became confusing. I also had a source data directory, which in that one you didn't have to append data or source. It just, the path was textures, texture name, and the data path you had to put data textures, texture name. So just a little bit of inconsistency. I need to get I have got tests which run, but the tests of the plugins, there's a bit of a problem with that. Having good testing to catch regressions is always the best, but I'm sort of flying a bit loose at the moment. Okay, nice. So it would have been more impressive if that had worked the first time without having to fix it, but it's fixed now. So that can go into... Cool. Okay, so now I can go, basically there's texture arrays and there's also cube maps, which I had on the list. I'm just going to update the to-do list. So textures with MIP levels, they're sorted, which is nice. DDS file, that was done. That's what I did quickly before the stream, just to kind of do a bit of legwork and tedious stuff and make sure I knew the kind of direction I was going in. So there's cube map, 3D texture, and texture array. I do have to have an example actually of that assigned distance field one, which would be useful to test. Creating texture with a heap. That's what I was mentioning before about giving the flexibility to create textures with the default device heap or your own, so then you can kind of create your own heaps and you can bind them independently. And you can also do things like ensure you only have textures in the heap and things like that, and then makes indexing a bit nicer because the current heap now has the render targets in there as well. And then the shader heap is textures and C buffers. So PMFX is the higher level graphics API, and my plan was that it would manage textures a bit more, like give it a bit more control as opposed to using the default device. And then it's all in one place as well, that other platforms might be able to leverage that. So before I forget, is like submit one command list for each texture, not mip. So that's at the moment we're submitting per texture per mip, flushing and waiting on a command list. Not ideal, really. I think that should be controllable ideally, where you could issue a bunch of loads and you could just make sure you wait on them before you use them. It starts to get a bit complicated though, but definitely it's going to be a performance thing. MIP levels, what's it called? Minlod, maxlod. Minlod, maxlod should be 0 to FLT, float max, whatever it is. I think it can take float max. That's default. Should be that. That's PMFX. Let's go back to, actually I want to make sure that I can hot reload code. Draw, so just going to change the cylinder to a cube. There was also the issue with the UVs actually being detected changes, building. $11 seconds. And it's loaded those again because it's just going through the raw API. The plan would be materials would be able to be created through PMFX and it would track them and keep hold of them, so we're not making duplicate loads, like a basic resource management system. But that has worked, so hot reloading is working again. Let's go and check out the shader, PMFX, debug HLSL, sample texture, albedo, cool. That's working as well as expected. Starts to get a little bit squiggly at the top, but that's fine. Right, so that's the, pretty good progress there actually. Still got a bit of time, so I'm not really doing anything, so I may as well just carry on. Submitting a single command list. Let's have a look. Oh, and there was also those validation warnings. Using a resource barrier on command list before state. Copy test. Barrier. So what's my barriers on the resource? Okay, so I only have to do it once, and then we can in theory be able to put a barrier in the command buffer think I can fix this by doing it once, and at least if it's once per texture. And the issue is we have to reset. I don't know how long they're going to take. It could have multiple command lists and rotate through them and then wait for the next one to finish before we reuse it. Really needs some kind of test or some sort of scenario. But for now, I think a first step would be per texture waiting like it did before instead of waiting per mip. A copy location. Resource barrier. How many do we have? Transition barrier. That's the buffer. It's not the resource. The buffer. The buffer's doing a similar thing as well. I'm gonna just try and see if I can do this again. Starters, I don't think that needs to be cloned. That's cloning references. Oh no, it is. We manually drop. So I think potentially command list copy texture using DST, texture location into the resource. It feels like this is the barrier is inserted after it should be anyway. It was erroring, so right, let's see. So the first things first, resource barrier, command list, close, command list, execute, signal, wait, reset. I think basically before I moved this outside and it crashed. Defense. Create a fence. I feel like it should be there. Create the fence, signal the fence. execute command lists, and then reset. What's this? Okay, so this is going from copy desk to the resource, and the resource is already in the copy desk, so that's why it should go after. Transition to requested. That's that. This one crashed before. Oh, clear. This has this sort of reflex type clear every time. Don't care about initial state in the inner function, but it's crashed. Yep, that was to be expected. Client debug. It was deleted prior to closing the command list. Source and desk copy location. Upload. A resource object. So it's because this resource upload is being dropped. So what do we have? We've got an upload resource, which we map, upload, map it. Then we've got the reso, take a reference. Okay, so this is weird, rusty kind of behavior. If I return the upload, manually drop. Upload is upload unwrap. What I'm gonna do. So at this point, I need to just keep that buffer alive. I'm gonna make a vec. low buffers. Especially drop and kind of GPU related things, how it links into Rust. You really sort of like feel the brunt of it a bit when things are dropped, they're in flight on the GPU and you can't do it. So you have to start kind of working against the general principle of kind of the memory model of Rust in a way. Keep things alive. Got a function in the device where you can pass it a texture. You want to keep the texture alive for subsequent frames, and then the texture can be dropped when it's safe. Upload resources. This can be an mut of a vec new, not a vec new, a vec of ID3D12 resource. The problem is here is if I'm taking a reference, I need to make sure that they don't move. Push. That means upload. Why does that happen? Resources upload clone. Res. Right. Doesn't have a back. So if I ensure they'll stay in contiguous memory, and the vector doesn't get resized, new value, damn. I can't resize it. And then not being able to not initialize stuff. Don't want to make clones unnecessarily. Back, we know it's the len. Upload resources back. Upload resources back. Upload resources back. Now, as long as that reference remains, upload resources. Okay. So if I resized it, I would expect the vec to not change, remain on the stack, and or the pointer to the vector remaining on the stack. But if it resizes, okay, well it's worked, which is quite nice. So let's have a go at 5 debug, just check debug console, and no error. because we're only doing the one transition. That fixed two things in one go, which was quite handy. I'm still slightly dubious here. It might be okay. It's as soon as you start getting into like even beyond the Rust ownership, then that ID3D12 resource is a COM object underneath, and so when you're cloning and taking references, you're kind of thinking, what's happening? You know, what is happening? Where is my memory? Sometimes with C++ or C, if I allocate some memory, you've got a quite tight relationship with the pointers and the memory there, and I've become very familiar with that over time. Whereas these details sort of, you know, sometimes at first sight I don't think about them. So, where's this print coming from? Does it print that when it loads a texture? Loads an image. Oh yeah, this double branch. Array layers, array layers. Just gonna leave it. I mean, that handles all the cases, but it's quite verbose. Image format not supported. I don't know where this one's printing out from. Print out the data path and the asset path if it fails. Well, that's a couple of things off the list. Anyway, submit one command list and fix the validation warnings. Get that into done. Min lod, max lod. Let's have a look. So that's in PMFX, which is actually at the moment I'm rolling out builds like no tomorrow releases. PMFX pipeline. Here we go. Min lod, max lod. So they are in there. This needs to be 0. And how do we do max value? Python 3 max float. Input sys float info max. Quite nice. So if I switch to PMFX dev, and if I edit my config to no longer supply that, I can run this. It's going to build the shaders, and we should see that there is no difference. I don't any longer need to supply perfect. So then if we go back to -1 to -1, a bit noisy. The albedo no way looks as sharp as the normal map, but I can see it. Let's go back to the normal map again, just because I like doing this. Oh, and we can put back the albedo multiply as well, I think. Okay, there we go. Dead noisy. Oh, so I suppose that's just something to think about or consider, why things are the way they are. So in kind of like new, sort of more recent games, I don't know, like in the last 5 years or so, shader aliasing, maybe last 10 years, became more of a thing. Because in normal maps, you've got very high contrast information, like the edges of a normal, and then the specular highlight is going to hit this, and that's going to become noisy and aliased. And also, if you have roughness and shiny and rough next to each other, you've got quite aliasing artifacts. Whereas like much older games, just with textures, like a texture mipmaps fairly well, because generally they're not as high contrast with such sharp details. And even when it's something like the albedo of floor, everything is kind of brown colored. So that's just like you're kind of seeing aliasing that you would get from specular there. And that's something I'm going to have to think about and address. Temporal anti-aliasing does help with that sort of thing. But there we go. Nice and smooth. Right, so all of that's working. How long has this been? It's been over an hour and a half, so I think I might have a rest now. What's on the to-do list? We fixed that. I need to roll out a build of PMFX shader. Cube maps, 3D texture array, creating a texture with heap, loading textures and materials from different locations, and then it's back to the C buffer material. I just wanted to have kind of a bit more data to play with here. So tidying up the C buffer or the push constants material, thinking about C buffer material, transforming normals and tangent space, and then can start thinking about lighting really, and executing direct. So they're the next things kind of on the horizon. I'm going to leave it there now, and